Tilt and impact sensor. In many cases, knowing the exact force and direction applied to a gadget is an overkill. Just knowing that a bottle has been tipped over is enough to know that the lid should close automatically. For simple cases like that, a 3-axis accelerometer is an overkill. We could use a simple sensor that can detect the shock of an impact or for being upside down. The tilt and impact sensor is a simple switch which closes a circuit when positioned in a particular way. They are very cheap, around $5 on eBay for a pack of 10. They come in a variety of shapes, but usually they're made of a tiny metallic cylinder with a thin copper wire coming out of one end. The cylinder contains wires or a metal ball. When the device is hit, or when its orientation changes, the wires or the ball comes in contact with the wall of the cylinder and closes a circuit between the cylinder and the external wire. It can be very sensitive, so care must be given to compensating for the sensitivity, otherwise we would be getting readings that look chaotic. We are going to ignore this sensitivity for now, but in our later lecture we're going to look at how we can compensate for this sensitivity using a function in our Arduino sketch. To put this circuit together, we'll just use the Arduino. No breadboard is required. We're going to need to do a bit of soldering in order to connect the sensor to wires, which we can then connect directly into the Arduino. I'm going to show how to do the soldering, but also have a link in the lectures note that you can use and find out more information and more hints about soldering for the first time. So what I have now is the tilt sensor and the 2 wires. I'm going to stick one of those wires on the metallic cylinder and the other one on the little copper wire that is sticking out of the device. To do that, I'm going to use lead-free solder. You can get these in any electronic stores. I'm also using this contraption here that allows me to secure the device and the wires. It's just an extra pair of hands for me. As far as my soldering iron is concerned, because the devices that I play around with are low power and very sensitive, I use a small 20-watt soldering iron. If I remember right, I bought it for around $40. So starting the soldering process, first I secure the tilt sensor on my contraption in one of its hands, and I remove the protective casing from the tip of the blue wire, and my plan is to solder that tip onto the metallic cylinder of the tilt sensor. It is a bit of an effort to try and get that little piece of wire as close as possible to the cylinder so that my solder then can stick these two together. So I'll try to get it as close as possible. Sometimes it doesn't even have to touch as long as it's close enough. Alright, looks okay now. So get my iron, melt a bit of solder on it, and then try to get the solder to get onto both the cylinder and the wire tip. And it takes a fraction of a second for the solder to solidify once I remove the soldering iron. So this first connection is now done. So I'm going to carefully flip the device with its blue cable sticking out of it over, so I can get the copper wire that's coming out of the device facing the other side. Expose the tip of the yellow wire. I have a link to a website that contains a really nice tutorial on how to solder properly. So I'm going to provide the link to this website in the notes of this lecture. So if you have never done soldering before, you want to get some tips and tricks, please follow that link. The same story here. Try to get the two little pieces of wire as close as possible to each other before I deposit some molten solder onto them. Also beware if this is the first time you've soldered something, that as you're soldering you get little bits and pieces of molten solder flying around. Doesn't go far, but make sure you don't have anything that can melt, like little plastic or things, or your phone perhaps. Make sure you do this job on a surface that you don't worry about damaging. Okay, second connection is now complete. So I'm going to remove the device with its wires from the contraption, and then continue by attaching it onto the Arduino. So all I need to do is insert one end onto VC power, so 5 volts, and the other end to one of the inputs. It could really be either analog or digital input. To make this device a little bit more robust, because I don't want the connections to come off, I'm going to use some electrical tape and tape the whole thing together. Okay, much better. So connect the blue wire to 5 volts power, and the yellow one to analog input 0. Plug the Arduino into my computer and upload a very simple sketch. It just reads the voltage in input 0, analog input 0. And I'll show you in a second what the output of the monitor looks like as I'm moving the sensor around. So you get lots of values. It looks like it's chaotic, but if you wait for maybe for about a second, then the value settles depending on the orientation. Typically it should be either 0 or very close to 0, accommodating for the effect of cows, or up to 1023. And this is the sketch. There's not much to say about it. It's basically the same as the sketch that we saw in lecture 13. We use the analog read function for analog pin 0, take a reading out of that and print it to the monitor. And that's how you can sense tilt using a tilt and impact sensor. Before moving on to the next lecture, please try out the questions for lecture 14.